How do we describe motion? Make a connection. Race cars zoom around and around a track. What could you say about the position and motion of the cars? We can tell where the cars are located and tell that it has changed position by where it is on the track. So we're going to find out about ways we tell about the position and motion of objects. Our vocabulary words are position, motion, distance, speed, velocity, and acceleration. Position and motion. You can talk about your location or position by comparing it to other objects. If someone asks where you are, you might say that you are in a classroom, or you might say that you're next to a table. Motion happens when an object changes position. Forces cause motion. Push a toy car and it goes in a straight line. Spin a top and it turns around many times. How do you tell if an object is moving? Follow and measure its position over time. Think about riding a bicycle. How do you know that you are in motion? You change position compared to the houses, trees, and other things that are standing still. Those things are your frame of reference. Suppose you were standing by the lake in this picture. How could you tell if the bike riders were in motion? You could tell that they were in motion if they got closer to you or past you. The girl can tell the bus is moving. Her frame of reference includes still objects outside the bus. Your frame of reference has a lot to do with how you see motion. Think about sitting on a bus. If you look at only the inside of the bus, you may think the bus is not moving. But if you look out the window, your frame of reference changes. You see that you are changing position compared to buildings. So you know that the bus is moving. You can measure the distance something moves. Distance is how far it is from one point to another. We often measure distance in units such as inches, feet, yards, and miles. In the metric system, distance is measured in units called millimeters, centimeters, meters, and kilometers or kilometers. The units we use depends on the distance we are measuring. Millimeters and centimeters are used for shorter distances. Meters and kilometers or kilometers are used for longer distances. How can you tell if an object is in motion? So we can tell that an object is in motion when its position has changed. You can measure short distances with a ruler or a tape measure. How do you figure out an object's speed? Well, you divide the distance the object moves by the time it takes to move that distance. You can use a stopwatch to measure the time it takes a runner to move a distance. Speed. Speed is a measure of how quickly an object's position changes. You can tell how quickly an object moves by measuring its speed. Some objects move so slowly that it's hard to tell if they're moving at all, like the snail in the picture. Other objects move very quickly. To find an object's speed, you need to know two things. Number one, the distance the object moves, and two, the amount of time it took to move that distance. Then you divide the distance by the time. Speed equals distance divided by time. Say you walked a distance of 10 kilometers. That's about 6 miles in a time of 2 hours. You could find your speed this way. 10 kilometers divided by 2 hours is equal to 5 kilometers per hour. This means you walked at a speed of 5 kilometers, or about 3 miles per hour. Objects do not usually move at the same speed over a long distance, so it is helpful to talk about their average speed for their entire journey. Think about a flock of birds flying north in the spring. The birds stop and start many times during their trip. Their speed changes from day to day. Suppose the birds fly about 6,437 kilometers, or about 4,000 miles, in about 31 days. Their average speed during the journey is about 208 kilometers, or about 129 miles per day. So you need to know what two measurements in order to find an object's speed. What are they? If you said the distance the object traveled and the time it took it to travel, you are correct. So here's some average speeds of animals. Snail, 0.045 kilometers per hour. Sloth, 0.13 kilometers per hour. Tortoise, 0.3 kilometers per hour. A sphinx moth, 53 kilometers per hour. A cheetah running is 100 kilometers an hour. Fastest baseball pitch, 168.7 kilometers an hour. A falcon diving is 320 kilometers per hour. Jet